Let's begin my today's session, and we will be further discussing on the propositional logic. Our today's topic is validity of arguments. First of all, we'll get to see in this particular lecture, what do we mean by argument? And if we are given a set of arguments, how the conclusions can be drawn with the truth table. We discussed truth table in our last class, where 5 sets of truth table were discussed. They were considered to be the primary truth table. One of them was the negation, another was conjunction, disjunction, implication, and by implication. So we are going to take the help of those truth tables in our subsequent problems of today's class. Now, before we get into the formation of truth table, first of all, let us try to understand what do you mean by these arguments. This particular topic, which is there in the unit 2 of your syllabus, is always required in every other units of your syllabus, be it group theory, be it graph theory, be it set theory, be it relations, functions, wherever proofs are required. These validity of arguments are always playing important role. Our first definition of today's class, it goes like this. So I'm going to write the definition first of all. You note down this definition in your copy. A finite sequence A1, A2, AN-1, AN of statements is called an argument. The final statement AN, that means this one, is the conclusion and the statements A1, A2, AN-1 are called the premises of the argument. So this definition is very important. Carefully observe that we people make statements always. As I discussed in my last class, that most of the time we make sentences, we don't make statements. But if we think that we have made a certain number of statements like A1, A2, ... AN, and you know the statements are those sentences whose truth value can be judged by true or false, then we have these statements with us. This sequence of statements, arranged sequence means the things have been arranged in a proper word, not in a haphazard manner. Say, for example, suppose I say like this, I have taken my lunch, and after that I'm making the statement, I am feeling hungry. This sequence is a wrong sequence. As you all know, both of the statements can be judged by its truth table. So these sentences are statements. But if I say that I have taken my lunch and I am feeling hungry, so that means maybe you will say that I am a glutton. So it is not a valid argument. Argument is I am feeling hungry and that's why I have taken my lunch. So therefore, you have to consider all your statements that you have made in a finite sequence, in a particular order, in a particular fashion. And the final statement which you are making, that is the statement number, the last statement. If you are making 10 statements, then the last statement, that means the 10th statement, will be called as your conclusion. And the first 9 statements will be called the premises, which give you to conclude about the 10th statement. And as a whole, from starting from 1 to up to 10, this sequence will be known as argument. Now, mathematically, if we want to express what does it mean, then I must say that an argument A1, A2, AN minus 1, AN is called logically valid a particular argument is called a logically valid argument if the statement formula A1 and A2 and A3 and in this manner AN minus 1 implies your last statement, which is the conclusion. And if I can say that, if I can show that this argument satisfies this condition, satisfying this condition, is a tautology, then we can say that this set of arguments A1, A2, AN minus 1, AN is logically valid. What do we mean by tautology? What is this? Suppose we have 2 statements P and Q. Now, if I can show that the statement P implies Q, or we are making the statements in such a manner so that the truth table of it reveals all the truth value, all the values, all the arguments giving you the true, all the arguments are true statements, no false statements are present, then such arguments, set of arguments, are called tautology. Okay, so we have seen that in truth table of negation, not all the parts are having truth value capital T. Some are having truth value capital T, some are having truth value false, so falsity. So that will not be considered as a tautology. Tautology is a kind of a truth table where all the conclusions are true. Similarly, contradiction is a kind of a truth table where all the conclusions are false. So if we have a set of arguments A1 to up to AN, which is in which the n minus 1 arguments are premises and AN argument is going to be the conclusion, then if the conjunction of all these n minus 1 arguments implies the logical conclusion, and then that set of arguments A1 to up to AN will be called logically valid if we can show that the truth table of this is a tautology. So we'll try to understand this particular thing by an example. If I do not give you an example, the thing will not be clear. to you. So my example goes like this. Example 1, suppose I'm making a statement like this. Small p is my statement. Acha, suppose capital X is a person who is 45 plus years old. Okay, capital X is a person who is 45 plus years old. Now my statement P is saying that the person X has got 2 doses of Covaxin. And statement Q is his chance of acquiring second strain of COVID-19 is his chance of not acquiring second strain of COVID-19 is 80%. These are the 2 statements which I'm making on the person capital X. After that, on the basis of my formation of the statements, I am making my argument as follows. I have not yet made the argument. My argument goes like this. My argument is, if the person gets 2 doses of Covaxin, this implies his chance of not acquiring second strain of COVID-19 is 80%. So P implies Q. Then suppose the person has got 2 doses of Covaxin. We can conclude from these two that his chance of acquiring second strain of COVID-19 is 80% indeed. So you can say, if you try to correlate this particular statement, this argument which I have made as a special case with the definition, you can consider this to be my A1, this to be my A2, and that to be my A3. Okay, and according to the definition, I need to show that A1 and A2, or A1 and A2 implies A3. What does it mean? This is it. I need to show that this is a tautology. What does it mean? That is, I need to prove that A1 means P implies Q, and A2 means P. Together, they imply the statement Q. So I need to prove that this particular statement which I'm making, this particular argument which I'm making, this argument is a tautology. If I can show that it is a tautology, then I can only conclude that this is a valid argument. So let us try to find out whether this argument is tautology or not in the next page. Okay. So we are going to make the truth table. First of all, I'm writing the statement P and then statement Q. The possibilities of the statements having the true value or false value are as follows. We can have both the statements to be true. The first statement P is true, the second statement is false. The first statement is false, the second statement is true. Both the statements are false. Okay, these are the possibilities. Now we need to know the truth value of the argument P implies Q. So we know from the truth table of implication that if both the arguments are, both the statements are true, then this is true. If the hypothesis is true, conclusion is false, then this is false. If the hypothesis is false, the conclusion is true, this is true. If both of them are false, this is true. So this is the truth table of the implication P implies Q. Next, what do we want to have? We want to have the truth table of P implies Q and Q. So let's see what is coming. Now from the truth table of conjunction, you know that when the end symbol is there, and these are the two statements, then both of them are the truth value of this will be true only if both of them are true. Otherwise, only if both of them are true. Otherwise, they are false, because the operator you are using, the connector which is connecting the two statements is AND. Okay, so what we are taking into consideration, we are taking the truth value of P implies Q, which is capital T, the truth value of Q, which is capital T, and here we can see that both of them are false, so this implies false. Both of them are true, so this implies true. Now one is false and the another is true, so that is false. So we have got the truth value of P implies Q and Q to be TF TF. Now what do we want to show? We want to show that what is the truth value of this argument implying that argument Q. Okay. Oh, sorry, just a minute. I am considering this truth value of Q. It is not a truth value of, I was showing actually P implies Q and P. Sorry, that is a mistake. This should be P. Okay, so there will be a little bit of change over here. Okay. So if I am considering P implies Q and P, so I need to compare these two. And you see, if both the truth values are capital T, then this should be capital T. If one of them is false, then the resultant is false. So we are actually getting TFF. Now let us consider the final column, which is P implies Q and P implying, what do I need to imply? Q. So I'm putting Q over here. Now you see, for this you need to consider, remember, you need to consider this particular column, which is your hypothesis column, with the column this one. So this is your hypothesis column now, and this is your conclusion column. Okay, now you see the hypothesis is true, so the conclusion is true, so this will be true. Hypothesis is false, conclusion is also false, so this will be true. Hypothesis is false, conclusion is true, so this is true. Hypothesis is false, conclusion is also false, so this will be true. And now we see that the truth table of this or truth values of this argument are all true, and therefore this implies that it is a tautology. It is a tautology, which concludes that the argument P implies Q and P, which implies Q, is a valid argument. So what is our final conclusion? Our final conclusion is that if the person has if a person takes 2 doses of covaxin, this implies that his chance of not acquiring second strain of COVID-19 is 80%. Now, if the person has indeed taken the 2 doses of covaxin, that implies that his chance of not acquiring second strain of COVID-19 is 80%. So he proved that this argument to be a logically valid argument. Now let us try to look at another example with the same set of statements which I have made over here. That is small p and small q. My example number 2 goes like this. Now I want to check the following argument. Suppose I am making the argument as follows. My argument is P implies Q, Q, and therefore P. So let us try to check whether this holds good or not. Okay, so we'll try to find out the truth value of that. What does it mean? It means that, so I'm writing over here that this is my statement A1, this is my statement A2, and this is my conclusion. So I need to check the truth table of, I need to check whether the truth value of this is a tautology or not. We need to check whether it is a tautology or not. Okay. Now, what does it mean? It means that if a person takes 2 doses of covaxin, that implies his chance of getting not acquiring the disease is 80%. And suppose his chance of acquiring the disease of not acquiring the disease is 80%. That together they imply that he has taken the 2 doses of covaxin. Now I'll first check what the truth table of this argument reveals. If it is revealing that all the truth values are true, that means it is a tautology, then it's all right. But if it is not, we are going to find out what could be the reason for it not being a tautology. So let us try to test it. Now, according to that, I need to check that P implies Q and Q, they together imply small p. So we need to check whether it is a tautology or not. First of all, I'm going to write the argument statements P and Q. Then we need P implies Q. So let us put P implies Q. Then we need Q. Q is already there. After that, we need to find the truth value of P implies Q and Q. Then we need to find the last one, which is P implies Q and Q, which implies P. So let us try to check what this particular truth table reveals. Now, the possible set of truth values for capital P, of the statements P and Q are TT, TF, FT, and FF. And we know from here that the truth value of this will be T, F, T, T. Now, P implies Q and Q. Now, you see, we have to consider these 2 statements. Remember, so both of them are true, then this will be true. If both of them are false, it is false. Both of them are true, it is true. One of them is false, so it is false. So we have got TF, TF. Now, according to our argument, this has now become our hypothesis, and that has now become our conclusion. Let us try to check what is happening over here. Now, hypothesis is true. Hypothesis is true and conclusion is also true. So this is true. Hypothesis is false. Conclusion is true. It is true. Hypothesis is true and conclusion is false. So that is false. Hypothesis is false. Conclusion is false. So this is true. Now you see that not all the truth values of this argument is true. And therefore, this is not a tautology. This is not a tautology. And so P implies Q and Q together implying P is not logically valid argument. What does it imply? Let us try to justify the point. Let us try to write it over here. Why it is not coming to be logically valid? Let us try to find it out. What is happening in this particular, what is wrong with this argument? Now suppose, according to the table that is being revealed over here, it is saying that P implies Q means if the person gets 2 doses of Covaxin, then his chance of not getting the virus is 80%. And suppose indeed the chance of the person not acquiring the virus is 80%, then we can't conclude that he has taken 2 doses of Covaxin. Why is it so? Because in this particular case, if this happens, it may so if this is the case, if it may so happen that probably he has got 2 shots of Covishield and not Covaxin, and therefore his chance of acquiring not acquiring the disease is 80%, or maybe he is immune to the system. Okay, this virus cannot affect the person. And we have seen such kind of situations in many Hollywood movies like World Z and I Am Legend. Okay, there is a person, 1 in billion, who is immune to the system. Okay, so the person, if gets 2 doses of Covaxin, then his chance of not getting the virus is 80%. And he has, it has been found that his chance of acquiring the virus is not acquiring the virus is 80%, doesn't imply that he has got 2 shots of Covaxin. This argument is logically invalid argument. But the previous one, that means this one is a valid argument. This one is a valid argument. Okay, and we can very well see why it is a valid argument. Now, what is if you look at this particular thing carefully, if you look at this particular charts carefully, suppose this is my chart 1 and this is my chart 2. Carefully observe what is happening over here. When this is becoming a tautology, and when it is becoming not, it is actually not a tautology. Look at the 2 columns, this column and that column. In this column and that column, the hypothesis column. Okay, this was my hypothesis column. Now in this hypothesis column, what we are actually finding over here? We are actually finding that hypothesis here is capital T and this is capital T. Here I'm finding capital F and here I'm finding capital T. Here I'm finding capital F and here I'm finding capital F and capital F and capital F. So there was no problem. But the problem which arose in chart 2 was this one. We found the hypothesis to be having the value T and the conclusion to be having the value capital F, and that created the actual problem. So if you observe carefully that to be a tautology, we shouldn't have an argument, we shouldn't have a column like hypothesis being hypothesis having the value capital T and conclusion having the value capital F. Okay, this particular pair is actually prohibited for your argument to be logically valid. Okay, and so this particular set actually created the problem, and it didn't make the actual argument to be a valid argument. Now, things become very clumsy and very, or I may say that very cumbersome when there are many set of arguments, like not only P, Q, and R. Suppose there are more than 2 arguments, like we have 10 arguments. Then to make the truth table and to get the solution becomes very hectic and tedious, because if we have n statement letters, actually we have to construct two to the power n number of rows, 2 to the power of n number of rows. Remember this formula, with m columns in it, with m columns in it. So for example, if you have 3 arguments, so according to the formula, we need to consider the truth table with the following set of triplets. Now we have, suppose we are putting capital T for P, then with this capital T in P, we can have the following pairs: TT for QR, TF for QR, FT for QR, and FF for QR. Same set will repeat itself for small p having the truth value capital F. So again, we are going to have this. Okay, so according to this particular formula, for 3 statements, we actually have to construct 2 cube, means 8 rows, and several columns. That is not defined. It depends upon what argument we have and what we are actually supposed to find out. Okay, so in these cases, in this scenario, the formation of truth table, or getting into the solution, or to check whether the arguments are logically valid or not, they become actually cumbersome. So to ease the situation, the mathematicians have already proved a set of arguments to be a tautology. They have found that they have a certain set of arguments which are always tautology, and they have given us this set of arguments and they have named them accordingly. Okay, so we are going to see now what are these valid argument forms. So if you can recall those valid argument forms, sometimes it becomes easier for us to solve the problems, to find the logically valid arguments from the set of arguments. Okay, the first, so my next discussion is on the topic some valid argument forms. Okay, so my first formula goes like this. First argument, if P implies Q for two sets of arguments P and Q, and we have P, then this implies Q. And you see, we have already proved it. We have already proved this particular set, this particular formula, this particular argument over here in chart 1. We have already proved that this argument P implies Q and P, therefore the conclusion is Q is a logically valid argument. Okay, this logically valid argument that is P implies Q and, or let us use the notation, and P together implies Q is called, this formula is called modus ponens. This formula is called modus ponens. It's a Latin word which means method of affirmation or affirming. Method of affirming. The formula which we have just now proved to be a logically valid argument is actually known as modus ponens. So you may ask me whether you are supposed to remember this particular argument or not. So answer is yes, you have to remember this. So just like this argument 1, there are several other arguments which should be memorized when we deal with a larger set of problems, with a larger set of arguments. Okay, we have to find out whether in this set of arguments modus ponens is hidden or hidden. If it is hidden, we have to extract it out, or the other set of arguments which I'm going to write in the next session of today's class, we have to find it out from a big set of arguments. Okay, so and you can very easily say that the chart 2, the argument is not a valid formula at all. So we shall not be considered, we don't have to remember this, we shall not consider it anymore. So remember this first formula, which is called modus ponens, known as method of affirming. I'm going to stop my video over here. We are going to meet in the next session.